Yes, class. Good evening, class. Good evening, Wafia. How are you all? Shall we start with the class? Yeah, Darshani, Rifat, Sahal, Sayyida, Rufia, and Wafia. All right, class. So in the last class, we had started with alternating current. We had completed the introductory part of it, as well as about the EMF. EMF sign value we had seen, whatever is the value of alternating EMF we had obtained in the last class. So today you'll be having the test as well also of EMI as informed already to all of you. But before the test, let's have few topics covered, then you will have a test. Test has, I think, only 4 questions. So 45 minutes to 40 minutes, 40 to 45 minutes will be sufficient for you. Till the time we have a small portion to discuss, let's discuss that first. Mean or average value of AC? Mean or average value of alternating current. Now see, alternating current is what? Current is variable, or even your EMF is variable. So if you have alternating current, if you have variable EMF, then what will happen? Different values of EMF will be obtained at different time. For example, at t is equal to 0, I'll be having a certain value of current. At t is equal to 2 seconds, I'll be having a different value of current. T is equal to 5 seconds, another different value of current. But how will I say what is the net current of the circuit? Until and unless I calculate the average of all the currents that I'm obtaining in the different intervals of time. So that mean value we are trying to calculate. What is the mean value of AC? Now this is calculated in 2 parts. First for one complete cycle and one for half cycle. Now what is meant by complete cycle? What is meant by half cycle? When we did AC dynamo, that's why we had done AC dynamo first. C class. When we did AC dynamo, what did I tell you? Different, you have the AC plate with you, the normal coil with you, magnetic fields are there. That rotates. And that's how it completes the rotation and you get your variable current and values, because the normal to this plane makes an angle of theta with the magnetic field, and as the angle keeps on changing, the magnetic field's value keeps on changing, your EMFs comes out to be different, your current comes out to be different. Fine. Now if we are considering one complete cycle and one half cycle, so complete cycle means what? Complete cycle means from here you have started the coil. At the whole completion of time period, one complete rotation has been done. This is known as one complete cycle. So whole time period T will be involved. But if I start this and I stop at this point, I do not complete this, I stop at this point only. So this is half of the rotation that is occurring. So it will be half the time period. Fine. That's what we will study for average cycle as well as for half cycle. Now see, first let's do it for one complete cycle. And these questions come, just the derivation part comes. So please pay attention. All these derivations part will come. So one complete cycle. It can happen that many things you'll not be able to understand. It's just the second class of AC only. So even if things you're not able to understand, don't worry about it. A very small topic has been covered. Now we have started a different topic. So from here, even you pick up, you will be able to manage. I think only EMI is left, and all the new students as well. For the new students or students who have missed some lectures, like somebody has missed a lecture. If I talk about Priya Darshini, she has joined from some class. Eman has, I think, joined from current electricity. Likewise, you all have joined from different chapters, most of you. So do not worry about the portions that have already been covered. See, many batches are almost towards their second book, and they'll be ending the syllabus first. So once that batches will have the syllabus completed, I'll be taking complete revision classes. So in that batches, or even in your batches also, full revision of starting from chapter 1 will begin. So even from wherever you have lagged, or left the lesson or joined from wherever. Do not worry about that. We'll be able to complete it. So for you, Evan, especially, I'm telling you here what happened. Normal current we have studied, that is known as direct current DC. Now we are studying alternating current, current that is variable. So AC dynamo, a very small topic only we had completed. Now we are calculating the mean value because different angles the coil is rotating, so there will be different values of current. So for one complete cycle, what will be the average value, and for half cycle, what will be the value, average value? That's what you're trying to find. So I'm again repeating, if any part you're not able to understand, stop me, I'll tell you the back history of it. All right.
All right, ma'am. Thank you.
Okay. Now, one complete cycle means exactly as I've mentioned, you have to write down the whole time period. So see, we had started with I is equal to I naught sine omega t. Remember in the last class we had seen E is equal to E naught sine omega t, where I naught and E naught, these are what? These are the peak value, and your current is varying sinusoidally. This is the current that you are calculating at a particular instant. Now see class, your charge, if I write dq, so dq over dt is I. So dq will be I multiplied by dt. That means I naught sine omega t dt. That is the charge. Now if I integrate both these sides, dq and this side, see what will I get. Without integration, this lesson is totally incomplete. Even you can survive without differentiation in this lesson, but integration is a must in alternating current. So all those who have their integration weak, please revise it once. Now see class, we are integrating it. So dq will give you q completely. I naught sine omega t dt, this is left. Sine omega t, sine theta, when you have no sine theta, that gives you minus cos theta. So here you have sine omega t. This becomes minus cos omega t. Whenever you are integrating, the constant term gets divided. Whenever you are differentiating, constant term gets multiplied. Here we are integrating, so this is left, and this I naught is left because this was already a constant, and limits from 0 to capital T. Why are we putting the limits from 0 to capital T? Because that is for one complete cycle. All right. Now we just have to find this. Q will be equal to what? C class. This is I naught by omega. This is minus cos omega t. Minus cos omega capital T minus cos omega, not omega t, directly 0 I'll write. This is 0 degree, no? That is cos 0. Omega has a relation with time period. Omega and time period have a relation with each other. That is, your omega is simply 2 pi divided by time. Omega is what? Omega is 2 pi divided by t. Now see, also I can bring this minus sign over here. Minus I naught by omega. Cos omega can be written as 2 pi by t multiplied by this t minus cos 0. See, tt gets cancelled. You have cos 2 pi. Cos 2 pi is 1 minus cos 0. Cos 0 is also 1. So this gives you 1 minus 1, that is 0 omega. So charge is coming out to be 0. If charge is 0, then what will be the current? Current will be 0. And so the EMF will be 0. These are very important conclusions. These can come in your theoretical questions as well as these whole derivations are definitely going to come in your exams. These sets of questions do come in the exam. So average value of AC over a complete cycle is 0. Remember, the values will be different for half cycle, that we'll see. See, half cycle, what will be the changes? Change will come in the time period. Do one thing, note this down, then I'll explain. First, note it down. Done, class?
Yes, ma'am.
All right. Okay. Now see, for a half cycle, no, if this is for a half cycle, the change that will come will be in the time period. See, because now the time period is not completed. T was the time period. Time period means the entire time that is taken by the coil to come back to its original position. Now we are talking about half cycle. So only half time will be covered if we are dealing with half cycle. So see, let me make a correction over here only for half cycle. This becomes T by 2. Till here, everything remains the same. This becomes T by 2. So if you have T by 2, this becomes cos T by 2. And here you have 2 as well. So 2 is there. Now you have cos pi. Cos 2 pi is 1. But what is cos pi? Cos pi is here 180 degree. 180 degree is not 1. That is minus 1. So from here is the difference that arises in the calculation of this. Q becomes equal to what? See, minus I naught is there. Omega, let's write it as 2 pi by t. 2 pi by t. Cos pi minus cos 0 degree. This is the change that will come. So Q will be equal to what? Minus I naught t by 2 pi. Cos pi is 1, minus 1, and this is minus 1. That makes it minus 2. So Q becomes equal to minus I naught t by 2 pi into minus 2. This 2 gets cancelled. Minus minus becomes positive. I naught t. This becomes I naught t by pi. Now see, this is the charge, but we want the average current. Average current will be what? Average current will be charge divided by the time period. Time is T by 2. Charge we have calculated, it is I naught T by pi, T by 2. See, TT gets cancelled. Final answer is 2 I naught by pi. So your average current over a half cycle, its value is 2 I naught by pi. And if you write it in decimals, it is 0.637 I naught. Fine. Similarly, you can write it for E average also, EMF average also, that is 2 E naught by pi, which is equal to 0.637 E naught, that is the peak value. This is the difference that will just arise. So do one thing. I hope this will become clear, because first part is clear, so this will become clear. Do one thing. From here, just till here, note down everything that you have written. You have to note down this exactly. Okay, note it from here only. I've made the corrections. Half cycle and T by 2 everywhere. Now time period becomes T by 2 because it is half time period. Fahad, we have just calculated the average current and average value of alternating EMF for full cycle and half cycle. Full cycle means when the coil of AC dynamo rotates completely, and half when the whole time period is just half T/2. So these two topics only we have done. This is the answer or the derivations ending for average, for half, and for full cycle it is 0. So that derivation is there. Just after the class, take the recording and have a look at it. Note this down, then we'll just calculate, do one more derivation. Now see, RMS value we will calculate. RMS, we commonly say it as RMS, full form is root mean square. But we do not perform root first, mean first, and square first. RMS value, root, mean, square. First you square it, then you take out the mean value, and then you take out the root value. This is known as IRMS, we commonly say, ERMS we say, or one more term is there. Virtual current also you say, virtual current or EMF, or even you can say effective current or EMF. So either of these terms is mentioned. Do not get confused. That is simply pointing to RMS. Now derivation here, this part, the derivation will be easy. See why. I is equal to I naught sine theta. We are doing what? We are first squaring. So you have to square current. I is equal to I naught sine omega t. We have to start from. Now to calculate I RMS value, what did I tell you? First you square the term. First square it. It means write I square. Then take out the mean value. So we take the mean value by, we just take the mean value by integrating this and integrating the same thing in the denominator. So your complete time we are calculating, so that is 0 to capital T. This will also be 0 to capital T. This is I square dt by dt. This is just the way of calculation of mean whenever you're doing integration. And whenever you're performing integration, you take the mean value like this for all the time period you integrated and divide by the whole time period. Lastly, mean done. Third is root. So a complete over root on this. You just have to now solve this. That will give you your answer. So put the value of I square. I square will give you I naught square sine square omega t, right? I square dt, integrating it from 0 to t. In the denominator, you have 0 to t only. See, integration of dt from 0 to capital T will give you capital T only, right? Capital T minus 0 will give you capital T. So I'm directly writing down capital T over here. Got it? Integrating dt from 0 to capital T will just give you T, 0T, that will give you capital T only. Got it? This is IRMS with an under. Okay, now we have to perform the integration. See, I naught, take I naught common, I naught square out of it. You are left with what? Integrating it from 0 to I naught square by T. Bring this T also apart. Now you are left with what? You are here only, you are left with, okay, let's just leave this T aside right now. Let's just leave this T right now. Let's just solve the above term. At the end, we'll add T, otherwise it will become confusing. I naught sine square, it is square. So whenever you have sine square theta, that gives you 1 minus cos 2 omega t divided by 2. This is how you write the integration of it. All right, this is how you write the integration of it. I'll write down the T as well over here. T I have kept. This is the integration of sine square theta. Within under root, all these terms are present. Fine. Within the whole under root, these terms are present. Now see, solving this further. dt integration means T. And here you have cos. See, now when we'll integrate this, cos 2 omega t will become what? C class. From here we have written cos 2 omega t, I naught sine square omega t was written by the identity as 1 minus cos 2 omega t by 2. Now we have to perform the integration as well. No, integration we have yet not performed. Still integration is left. So now when you will integrate it, you will get sine back. So dt multiplied by 1 will give you t minus cos 2 omega t will give you sine 2 omega t divided by 2 omega. Why? This term was already there. Omega comes in the denominator when you multiply. And what all is left? 0 to capital T is the limits for it. I'm not writing the power, the root. We'll put it under the root right now. And what is left over here? Over here, I naught square by 2 is kept. That 2 I have brought over here. This 2 is because of 2 omega t. This 2 I have brought over here. Got it? I naught square by 2 and 1 minus cos 2 omega t. Integration gives you sine 2 omega t by 2 omega. Cos 2 omega t gives you sine 2 omega t by 2 omega. This 2 was left, so that I have written over here. Leave this t and under root right now. First, find out the value of the square. Mean value, if you find out, then you can put it under the brackets. Under root, you can write it. Now, what is left? I naught square by 2 is there. Here, this becomes capital T. This becomes sine 2 omega t. So you have sine 2 omega capital T by 2 omega minus. Okay, do one thing. 1 by 2 omega, keep it like this. Now your integration of sine becomes easier. This becomes sine 4 pi capital T into T. How I have written? You have 2 omega. So 2 times 2 pi by capital T. That gives you 4 pi by T. That's what I've written. Now, you have to put the limit because the limits are from 0 to capital T. Limit still not we have substituted. Now, let's put the limit. I naught square by 2. This just at least we have resolved it. 1 by 2 omega has been taken common. Now, see what is left. T minus 1 by 2 omega is there. Now, write down the powers. This becomes sine 4 pi because capital T will get cancelled. See, sine 4 pi by t is there multiplied by capital T. That will give you just so sine 4 pi. So sine 4 pi I have written minus this sine 0. So I naught square by 2. This gives you t. See, sine 4 pi minus 0. That will give you 0 because this is 1 and this is also 1. This is 0. This is 0 and this is also 0. So here this 0 minus 0, that will become 0. So this whole term will be 0. So you just have t left. This is what? This is the mean value that we have calculated. Now the t that was left, now you can add t everywhere. And under root now you can add, because otherwise writing under root was becoming very difficult. T you can write it anywhere, or if you wish you can leave it like this. Leave it like this, and at the end add your capital T and your under root. Now see, capital T is left. So I average comes out to be what? I naught divided by root 2. Similarly, ERMS, not average. Average we have calculated. This is RMS. So ERMS, this is IRMS, and ERMS comes out to be E naught divided by root. Got it? This is the whole complete derivation. Let me repeat it, because many mathematical terms were used, so this can be confusing for all of you. See, you just have to solve this. First, you have to square I, take the mean value, and I have told you mean value is taken like this only. Integrate it and divide it by the total. And for the root, put an under root at the last. Then I naught's value has been kept, and this using this identity, we have written 1 minus cos 2 omega t by 2. Sine square omega t, no, that is written as 1 minus cos 2 omega t by 2. Then integrate this, you get sine 2 omega t by 2 omega here. And when you take 1 by 2 omega common, sine 4 t by pi by t is left. When you put the values of the integration, you get sine 4 pi minus sine 0. That ultimately gives you I naught by root 2. I've repeated it once very briefly. Do one thing, note it down at whichever step you're not able to understand. Let me know. I'll repeat that particular step. It can be confusing because whole lot mathematics is, but math students must not be having any difficulty. Just start copying it from here. Sine is there in the first step. Which first step? See, this is I square. Then we keep the value of I square, that becomes I naught sine omega t square. I is I naught sine omega t. So I square will be I naught square sine square omega t.
Ma'am, can you scroll up just a little bit? The last.
Done class? Written till here? Just text done in the chat column when you've written. Okay, Rifat has done. Or others also. Once you have written it, just text me done. Alright. Aman, in your batch, electromagnetic induction wasn't done, no? So I think you must not be doing knowing it. So see, I mean, you can now just take the screenshot of the paper and keep it with you. Others, please appear for your test of EMI. Four questions are there: self-induction, then you have Lenz's law, then you have motional EMF, and then you have induced EMF. Right? Yes, Priya Darshini, I have received your sheet. You can also leave. Thank you so much. Okay, yes, Wafia received.